Today's topic is going to be over multiplying mixed numbers from Unit 5. By the end of this lesson, you'll be able to find the product of two mixed numbers by using partial products and adding them together, or converting the mixed number into an improper fraction and multiplying it. You'll know you'll have it when you can find the product through multiplying with either strategy and correctly finding the answer. Some vocabulary that will be important to know is numerator, which is the top number of a fraction, the denominator, which is the bottom number of a fraction. Simplifying means reducing a fraction to its simplest form. Mixed number is a number consisting of an integer and a proper fraction. And then finally, an improper fraction is a fraction where the numerator is larger than the denominator. When multiplying mixed numbers, we can use either strategy to find the correct product. The first strategy that we will talk about is partial products. I'm going to break down my mixed numbers, multiply different parts of them, and then add them all together. Or I will change my mixed numbers into improper fractions, multiply my improper fractions, and then I will simplify that fraction back into a mixed number. Let's look at our first example. I have 4 1/3 times 3 2/5. If I'm going to use my partial product strategy, the first thing I want to do is draw a box that has 4 pieces. I'm going to divide it into 2 columns and 2 rows. I'm going to take my first factor and I'm going to write the integer over the first column and the fraction over the second column. Next, I'm going to take my second factor and I'm going to write it on the rows. So I'm going to take my integer and write it next to the first row, and take my fraction and write it next to the second row. This is going to be like a box multiplication method. So here, you'll see I'm going to multiply 4 times 3. Here, I'm going to multiply the integer and the fraction 3 times 1/3. In this box, because it lines up with the 4 and the 2/5, I'm going to multiply 4 times 2/5. And in this box, I'm going to multiply the 1/3 and the 2/5. 1/3 times 2/5. I'm going to do all of that math before moving on to my next step. So first, I know that 4 times 3 is going to give me 12. Now I'm going to multiply 3 times 1/3. So that's really just 3 over 1 times 1 over 3. That's going to give me 3 over 3, which I know equals 1, because anytime a numerator and a denominator are the same, that's going to give me 1. Next, I'm going to multiply 4 over 1 times 2/5. So 4 times 2 is 8 over 5. So the answer to that is 8/5. And then finally, multiplying 1/3 times 2/5, that gives me 2 over 15. Now I'm going to take all of those numbers and I'm going to add them together. 12 plus 1 plus 8/5 plus 2/15. To simplify this, I know that I can add my whole numbers together. That's going to give me 13 plus 8/5 plus 2/15. To add fractions, remember I need to find my least common multiple. I know that 5 can be multiplied to create 15 when I multiply it by 3. Whatever I do to the bottom, I have to do to the top. So now I'm going to rewrite this with my equivalent fractions. 13 plus 24/15 plus 2/15. Because my two denominators are the same, I can add my two numerators to combine those fractions. Now I have 13 plus 26/15. What I can do now is I can simplify that 26/15. I know that 15/15 is going to give me 1. So subtract 15 and move that 1 over to the 13. I have 14 plus 11/15. Can 11/15 be simplified anymore? It cannot. So my product is going to be 14 and 11/15. This is great for when you have numbers that might be bigger, so we don't have to change them to an improper fraction, or if you can see the numbers easily. Now let's look at our second way of doing this, and that would be by changing them into improper fractions. Okay? So I know that to change this into an improper fraction, I can multiply the integer by the denominator and then add it to the top. So to change this mixed number into an improper fraction, I'm going to say 4 times 3 gives me 12 plus 1 is going to be 13. So the improper fraction that represents this is 13/3. I'm going to do the same thing here. 3 times 5, I'm going to multiply, and then I'm going to add it to the numerator. 3 times 5 is 15, plus 2 is 17. Now that I have improper fractions, I'm going to think back to my last skill and say, okay, when I multiply fractions, I know that all I have to do is multiply across. Numerators get multiplied, then denominators get multiplied. So I'm going to use this. I've got 13 times 17. 7 times 3 is 21. 7 times 1 is 7, 8, and 9. Drop my 0. 3 times 1 is 3. 1 times 1 is 1. Add those together. I have 1. 9 plus 3 is 12. Carry my 1. So I know 13 times 17 is 221 over 3 times 5, which is 15. What I can do now is simplify this. I can use my division algorithm to find what the numerator would be and what the remainder would be. So let's go ahead and do that. Or I can think, how many times can I multiply 15 to get close to 221? I know that these numbers are a little bit bigger, so I'm actually going to do some long division to try and help me figure it out. 221 divided by 15. I know 15 goes into 22 one time. 22 minus 15 is going to give me 7. Bring down that 1. How many times can I multiply 15 to get close to 70? Well, I know 15 times 4 is 60. Now I don't have any other digits to bring down, so I'm going to stop when I hit my remainder. Now, let's put this, or let's create the mixed number that represents this. Whenever I have a remainder, I really have a fraction of an equal group. So my quotient actually becomes the integer of my answer, and then my remainder becomes the numerator of my fraction. If you look here, we got 14 and 11 over 15, and we actually got the same answer here. So either way, we should be able to arrive at the same product.